Our 10th example we have, we need to shade the region according to this rule here, where we've got 3 times the real part of z squared plus 2 times the imaginary part of z squared is less than or equal to 36. Now, by letting z equal x plus yi, we can see that this inequation is going to translate to 3 times the real part of z is x, so 3x, that's all squared, plus the imaginary part of z times 2, which is 2y, that's all squared, is less than or equal to 36. Now, this here we need to be able to recognise is an ellipse. Okay, so we'll just expand this a bit more. That's 9x squared plus 4y squared is less than or equal to 36. Now, with our ellipse, we want our right hand side to be the number 1, so we divide throughout by 36. So we've got 9x squared over 36 plus 4y squared over 36 is less than or equal to 1. We can do some cancelling here. We know 9 goes into 36 4 times, so that's x squared over 4 plus, in this case, y squared over 9 is less than or equal to 1. We can write these here in the form, we want it in the form x squared over a squared plus y squared over b squared equals 1. So we've got here then x squared over 2 squared plus y squared over 3 squared is less than or equal to 1. Okay, now because it's just x squared and just y squared in the numerators, we know then that the centre of this ellipse is at 0, and our semi-major and semi-minor axis lengths are 2 and 3. So in the horizontal direction it's 2, so we can put here 1, 2, 1, 2, we know it passes through those points here, 2 and negative 2, and this other one is 3, so we can go up 3 and down here at negative 3. So our ellipse see if I can just make that, tidy that up a little bit. Alright, so that's our ellipse. Now it is less than or equal to 1, so we're going to shade inside our circle, our ellipse. Okay, let's have a look at the next example. Alright, example 11. Represent on the Argand plane complex numbers z such that the modulus of z minus 1 equals the modulus of z plus 2i. This particular relationship that we have here does not include a less than or equal to sign or a greater than, so there's not an inequality, which means it's actually not going to be a region. But I've included this example in here, not for the region's purpose of it, but because it's an interesting example just to be aware of. If we have a look here, normally when we're graphing something like this, we expect a circle. That's it would be if we just had a number here. Alright, but we've got a modulus either side here. So the best way to approach this one is to do what we've done with the last few examples. Let z equal x plus yi and see where it takes us. Okay, so if we rearrange or change this, we've got x plus yi minus 1 equals in the modulus of x plus yi plus 2i. Now, let's just group these together. So we've got our real part here, which is x minus 1 plus y I, and on the other side we have x plus and then y plus 2 is our imaginary part. Alright, now modulus, remember, is found by the square root of our real part, square root of our real part squared plus our imaginary part squared. So that's what we can do here. We've got square root of x minus 1 squared plus y squared equals the square root of x squared plus y plus 2 squared. Solving, okay, we need to rearrange this, get it as simple as possible. Take the square both sides. So we have x minus 1 squared plus y squared on the left, and x squared plus y plus 2 squared on the right. And let's expand all of these. So we've got x squared minus 2x plus 1 plus y squared equals x squared plus y squared plus 4y plus 4. And we can see we can do some cancelling here. X squareds, when we subtract, are going to cancel. Same with our y squareds. And then when we work further, we can bring things over to the other side. So we've got 4y plus 4. We may as well just rewrite that. Negative 2x plus 1 equals 4y plus 4. So then by subtracting 4 from both sides, we end up with minus 2x minus 3 equals 4y. And dividing throughout by 4, we'll end up with y equals negative a half x minus 3/4. And we can go ahead and sketch this line. Y-intercept of negative 3/4, so that's here, pass through that point, and a gradient of negative 1/2. Or we could just find out what the other x-intercept would be. So when y equals 0, we've got 3/4 equals negative 1/2. X, and then times by negative 2, so we end up with negative 6/4 equals x, or negative 3/2, or 1.5. So it passes through that point there, and then we can draw our straight line through that. And so that's our point there. Okay, labelling those intersects. We've got 0, negative 3/4, and here negative 1.5, 0. Okay, so that's that one. And then we'll look at our last example. We'll do that here as well. Example 12. Okay, this time we've got the real part of z minus 1 times the imaginary part of z plus 1, all being greater than or equal to 1. So we're going to take the same approach by letting z equal x plus yi, so that we have the real part of x plus yi minus 1 times the imaginary part of x plus y I plus 1, all greater than or equal to 1. So our real part is going to be x minus 1. We need to multiply that by the imaginary part, which will be y. That's greater than or equal to 1. Let's rearrange that. And when we do rearrange, we want to get our y on the left hand side. We need to take or put the x minus 1 over to the right hand side. Now remember, when we're dividing or multiplying and we have inequalities, we need to consider the sign here. Right, now currently it's greater than or equal to 1. Now the sign will remain unchanged if we multiply or divide by a positive value. Now this here, okay, this little expression x minus 1 will be positive when x is greater than 1. Okay, so let's consider the possibility. Let's consider it as x minus 1 greater than 0, i.e. x greater than 1. So when this expression is positive, y will be greater than or equal to 1 over x minus 1. So we're dividing by x minus 1, and this is the case when x minus 1 is greater than 0. But if x minus 1 is less than 0, in other words, when x is less than 1, then y is going to be less than or equal to 1 over x minus 1. Okay, so these are two possibilities, so we need to consider both of these conditions. So if we just sketch our plane, we know this is a hyperbola and it's going to have a vertical asymptote at x equals 1. Okay, so it's just the regular hyperbola, just translated 1 unit to the right. So x equals 1 is our vertical asymptote, and it's going to have our graph, a curve shaped like that, and also like that. And our y-intercept here is going to be, well, when x equals 0, it's going to be 1 over negative 1, which is negative 1. Alright, so this condition here, y being greater than or equal to 1 over x minus 1, that is for x values greater than 1. So on the right hand side, we shade here. For values of x which is less than 1, okay, so for the left hand side of our vertical asymptote, y is less than or equal to 1 over x minus 1. Okay, so we've shaded, and we have a solid line because of the equals sign. Okay, so that's really important to consider. When you're dividing or multiplying, you need to consider, is it positive or negative, and which will affect the direction of your inequality sign. So hopefully that's nice and clear, and then we can go on. That's the end then of our teaching for this topic, and obviously this is not applicable. I'll need to change the number of videos here, so it's no longer 26, and it's more like about 20. So it didn't take quite as long as what I thought when I did it. Okay, so any questions, come and see me and we'll go through it, and then we can get this topic done and dusted. Alright, thanks very much.